All right, so this is May 2016, question number 11. And A says, the position vectors of points A, B, and C relative to the origin are OA is 2, -2, OB is 6, 1, and OC is 10, 4, respectively. We're to express in terms of, in the form XY, the vector AB. Now, from triangular vector AB would be equal to AO plus OB. AO is minus OA, so it's minus OA, which is 2, -2, plus OB, which is 6, 1. So this would be -2 plus 2 plus 6 plus 1. And so we have 4, 3. So AB is the vector 4, 3. AC, triangular vectors. AC would be equal to AO plus OC. So AO is minus OA, so it is -2, -2, plus OC, which is 10, 4. So this is -2, 2, because a negative times a negative is a positive, plus 10, plus 4. And so this is 8, 6. So this is 8, 6. 8, 6 is the same as saying 2 is common, so you can put the 2 outside. 4, 3. All right. Then it says, hence determine whether A, B, and C are collinear. A, B, and C are collinear. Well, let's find out. You have A, B, and AC. All right, so I would say AB. All right, I'm going to draw an illustration just to give you an idea as to how the vectors line up. The answer is yes, they are collinear, but I'm going to give an illustration as to how they line up. This is A, this is B, and this is C. Now AC, from A all the way to C is, from A to B is 4, 3. From B to C is another 4, 3. And from A to C, so AC would be equal to 2 times 4, 3. That's what it is. This is how the three vectors line up. So hence determine whether A, B, and C are parallel. So I would say that AB is equal to BC, sorry, which is equal to 4, 3. So therefore, A, B, and C are collinear because AB and BC are parallel and they share a common point. So if two lines are parallel and they share a common point, the two lines form a straight line. The word collinear means in the same straight line. The word collinear means in the same straight line. How do we show that two lines are collinear, or 3 points are on the same straight line? Show that the two vectors are parallel once they're parallel and they share a common point. So A, B, and they share a common point, and the common point that they share is B. So you have AB and you have what? BC. They're parallel and they share a common point. Therefore, the 3 points are in a straight line. The vectors AB and the vector BC are what? Parallel, and they share a common point B. Therefore, A, B, and C are collinear, or they are in the same straight line. All right, let's turn the page. All right, B says determine the value of x for which the matrix 3x 2, 4 is singular. Now, if a matrix is singular, its determinant is equal to 0. So let's find the determinant of this matrix. Now, the determinant would be equal to 3 times 4, 3 times 4 minus x times 2. And so this is 12 minus 2x, and this must be equal to 0. Why 0? Because we're told that the matrix is singular. Or in order for if the matrix is singular, the determinant would be equal to 0. So therefore we'd have 12 is equal to 2x. Negative 2x goes over and become positive. Divide both sides by 2. And so x would be equal to 6. So in order for the matrix to be singular, x has to be equal to 6. All right, so C says N and P are two by two matrices such that N is 4, 1, 3, 2, P is 1, 5, 2, 1. We're to determine NP. So NP means that we must multiply N and P together. This is 4, 1, 3, 2. This is N. Multiplied by P, which is 1, 5, 2, 1. Multiply row by column. First element in row, first element in column, second element in row, second element is in column. So top row, left column, 4 times 1 is 4, 1 times 2 is 2. Top row, right column, 4 times 5 is 20, and 1 times 1 is 1. Bottom row, left column, 3 1s are 3, and 2 2s are 4. Bottom row, right column, 3 5s are 15, 2 times 1 are 2. So NP would be the matrix 6 here, 7 at the bottom here, 21 here, and 21 here, and 17 here. Thank you, Alia. All right, so we have NP. This says, given that Pn is equal to that, determine whether matrix multiplication is commutative. All right, now, since NP, since NP is not equal to Pn, everybody can see that they are not equal. The multiplication of matrices is not commutative. All right. So an operation is commutative when for all values when you switch around the values, the answer comes out to be the same. So here we multiply n by p and p by n, and they did not come out to be the same. So the multiplication of matrices is not commutative. For an operation to be commutative, when you switch around the numbers, when you apply the matrix, apply the operation and switch around the values, and you end up with, and the answers are different, we say that they are not commutative. In order for them to be commutative, NP would have to be equal to Pn. Since they are not equal, the multiplication of matrices is not commutative. All right, let's proceed. This says determine n inverse. Now n inverse is equal to 1 over the determinant of n times adjoint n. All right, now n, y'all don't remember, but n is the matrix 4, 1, 3, 2. So the determinant would be 4 times 2 minus 1 times 3, 8 minus 3, the determinant is 5. So n inverse is 1 over 5 times adjoint n, 2, 4. You switch around the leading diagonal elements. The lagging diagonal elements stay where they are, but their signs change. Multiplied by 1/5 is the same as saying divide by 5. So this is 2 over 5 minus 3 over 5 minus 1 over 5 and 4 over 5. This is n inverse. Then we're told hence calculate the value of x and y, for which n multiplied by x, that is equal to 1, 2. So let us say this is n, x is equal to b. To solve this, x would be equal to n inverse b. So therefore, x, which is what we want to find, x, y, is equal to n inverse. Let's use this version of n inverse. 2 minus 1 minus 3, 4 times b, which is 1, 2. Multiply the two matrices and then multiply by the fraction. 2 times 1 is 2. 2 times 1 is 2. All right, let's just double check to ensure that it is n. 4, 1, 3, 2. It is n. All right, you switch those two around. These two stay where they are, but their signs change. So far, so good. 2 1s are 2, and minus 1 times 2 is minus 2. Minus 3 times 1 is minus 3. And 4 times 2 is 8. And so this is equal to 1/5, 0, 5. Multiplying by 1/5 is the same as divide by 5. And so the matrix X, Y is equal to 0, 1. All right, we're asked to determine the value of X and Y. So therefore, X is equal to 0 and Y is equal to 1. All right, and that would be the end of the question and the end of the exam.